Hayden Land. Hayden Land is an executive from Lockheed Martin. He spoke with the Kent Learning Collaborative in November. He's going to talk about workforce needs of the future. So we found out kind of what you all think STEM is. We told you here kind of what we think it is. Let's see what a business thinks it is.
From a STEM perspective, 25 years ago, when I was an early professional, the United States was #1 in STEM, science, technology, engineering, and math. And in a recent survey and analysis by the World Economic Forum, they ranked the United States 52nd in the quality of mathematics and science education in the world, and 5th and declining in overall global competitiveness. Regarding the evolving careers, a typical scientist and engineer that I have in my organization today, they are great problem solvers. They have a problem, they break the problem down, they get rid of the dust, and they find the answer, and then they can act on that answer. Artistic or creative people, they can start with an idea, expand the idea, connect it in different ways, and go in multiple directions. A lot of the jobs that we're starting to see emerge today, such as data scientists, neuromorphic architecture, web archaeologists, nanocomposite engineer, cyberfractologists, biomimicry analysts, which will likely be some of the top jobs of the future, like many of the top jobs today didn't exist 5 years ago. They're going to require people who can do both, convergent thinking and divergent thinking. So the integration of multiple disciplines, be in position to obtain and succeed in dual degrees, be a psychological computer scientist, a medical mathematician, a sociological engineer. Those type of converging disciplines and having the left brain and the right brain be able to send signals back and forth, I think is something that I'm looking for from education.
So Hayden Land is Vice President of Civil Programs for Lockheed Martin, huge contractor for the government, defense, aerospace, etc. So somebody had mentioned STEAM, S-T-E-A-M. Is that you?
Yeah.
Phil?
Yeah.
Phil. So he was just talking about some of that, right? Artistic thought, taking an idea and expanding it, and wow, look at all this stuff that we can do. Or break it down, what's the problem, what's the issue right there, okay, that's what we need to focus on. And being able to do both. So the artistic thought, if you're designing something, like when we talk about some of these lessons later, if you're coming up with a solution to a problem, you kind of need to be able to think that way. And that's kind of what you said.
Biomimicry analyst, you mentioned a biomimicry analyst. Anybody have any idea of biomimicry? Have you heard of the term? We're going to show you a lesson later on. Very creative people, very artistic. So, but it's an engineering field. Be creative people.
Okay, why are we here? We want you guys to come away with a couple of things. First is your understanding, not ours necessarily, but your understanding of this idea. STEM is just an acronym for science, technology, engineering, and math, which are disciplines used together, cross-discipline thinking, okay, in industry to solve a problem. And then we'd also like to have some kind of a perspective, personal perspective on using those tools to solve real-world industry problems adds value for your students in terms of how they think. Why do I have to take your science class? When am I ever going to use this math class? That type of thing. Also, empirical value of just those skill sets, the welding jobs and things that we were talking about. If you teach your math using that, when they leave, they've got a little bit of background in that. And now, not only can they do the math, but they can also speak intelligently about welding, sheet metal forming, rivet, etc. Okay? You also are giving them kind of some career exposure, some pathways. Hey, did you know this existed? Nope. Now I do. Kind of cool. Want to know more about it. And then kind of a feeling of empowerment of your ability to successfully create lessons. That's why the whole second half of the day, that's what we're going to focus on. You guys building a STEM lesson. Is you or me? Me? Doesn't matter.
Go ahead.
Okay, so kind of more of that STEM argument, right? It's basically studying everything that's out there. Ourselves, how we interact with the world, why things work the way they do, why in thunder it is that when I plug this in, something lights up over there, why it is I can push this button on my flight management system and it'll fly me to China without me having to do anything else, okay? Just a bunch of things happening one right after the other, but figuring out how that works. It develops those analytical skills, skepticism, the value of drawing conclusions. You guys can read. They will be needed in other areas of the workforce. Rick has lots of stories of engineers that he brought into his firms and put them in sales. Because now, if I'm talking to you about, God, you got to buy this, Autodesk 360, right? It does this amazing stuff, and when you're designing that bracket or that wheel or that rim or whatever it is you're doing, now I can tell you more about this product that's going to help you through that process because I understand the process. Right? So managers, that's my background. I was in leadership at FedEx. Most people don't know FedEx has one of the largest airlines. I did turn it back. So it's going to be needed elsewhere. It also builds those 21st century skills. Maybe a little bit tired of that exact phrase. How many of us have heard that lots and lots? 21st century skills. What the heck do we mean when we say 21st century skills? Okay.
Programming.
Programming. Okay.
I just say technology.
Okay. How about knowing how to make an argument? Okay. I want to sell this product. I want to go with this design because it has these 5 things that are better about it. It'll be cheaper to manufacture. It'll be quicker to manufacture. It'll cost less money. It'll be twice as strong as yours because it's made of nanocomposite instead of whatever, aluminum, steel, something. Okay? Knowing how to present that, that is one of those skills that they're talking about. How to think. You're teaching people how to think. So some of the stats on this. You can see here where we're getting them from. Technical services up 29%. Computer systems and design, I've got cousins that are working in that field, up 47%. But look at this. Management, scientific, and consulting services, up 58%. So not just the engineer doing it, but the person explaining it, managing the people that are doing it, running the business, coming up with a new business. Okay? Lots of folks need to be STEM literate, okay, so that you can, again, make some of those arguments. You want to grab here?
Sure. We've got a third person, Trudy Brown, if you ever heard her name. She does career readiness, and she manages a lot of this. But just she got for us, or what she puts out is the top majors right now. You can see all the engineering, information management, geology. But like we said earlier, high demand for all of these skills right now. And also, right now, for every STEM job, there's 1.1 job for every one unemployed person and 5.8.
Unemployed people for a non
Oh, unemployed, right, didn't read that right.
There we go.
Yeah, so now the graphic makes sense down there. We're just demonstrating where the jobs are at right now.
This change the equation is Michigan specific, you guys. That's us, the mitten.
Can you go back to the previous slide by any chance?
Yeah.
I just want to see a few more.
Can we get a copy of this PowerPoint?
No.
We've got a Google Drive set up, and we did not email them. Did you check to Google Drive? Is that correct? Did not.
Okay, let's ask. Did you get it? You got it?
Yeah.
Did anybody not get that? Okay. There's also a link to it at the end of the, like I put it in last night, very end of the PowerPoint. So
Okay.
we'll make sure you guys have the tools.
And again, all those jobs, even when it says engineer, like software engineer, there's a whole lot of software technicians, a whole lot of people writing software that have no engineering degree behind them, but they know how to write software.
The manager down at Mutually Human Software, downtown Grand Rapids, didn't even go to college. Didn't even go. He runs the company.
So project-based learning, a lot of what we do in STEM is hands-on, which is project-based learning. We really want to differentiate today when we talk about project-based learning. We're talking about project-based learning that ties to an industry activity. So we're not just picking a project and saying because it's got technology and engineering, it's project-based STEM. We're really focusing on STEM is a link to industry. That being said, as a basic structure of project-based learning, BIE, Buck Institute of Education, has great information. They've got a really good professional development set up to learn how to do the basics of project management. Actually, yeah, let's pass. These are 3 of their books. just want to pass them on and leaf through them. But it goes through setting up the whole structure, how you set up the kids, how you set up the assessments, how you build the questions, how you structure your whole lesson format. So today isn't about that. Today isn't about learning about project-based learning, but we wanted just to address it and mention it and hopefully give you some resources on how to get more information. Things like they've got rubrics on their site. They've got a ton of rubrics, a ton of lessons. So BIE.org.
Free stuff, guys.
You
Teachers
got
love free
rubric over
stuff.
here. You pick which, what audience, what grade you're in. If you're a teacher, subjects. Where you're at, high school, project-based, middle school. So again, because of time, I'm not going through all of this, but when you do get time and you want to know more about project-based learning specifically, great site to go to. They do have a lot of example projects also, and we'll talk a bit about this later, how to build your own projects. But if you're looking for a starting point, some great hands-on projects right on that site, ready to go.
What about that guide on the side, too, Rick? Just with guide on the side. So when most of us were in school, teacher stood up front, tell. Students sit in the seats, right. Test. I give back the teacher what he or she just told me, right? Not all of us are engineers, okay? Not all of us have a background like Rick's or myself or some of you guys who did this stuff in industry. So understanding that what you're probably going to do is say, okay, I need you guys to understand the quadratic equation. Here's where it's applied. I need you to design me a, okay? Don't care what it looks like, don't care how you get there, but along the way we're going to learn this piece of math, okay? And you and the students will come together and figure out how you're going to get there, okay? So if you don't know all about that stuff, perfectly okay. Student learning is deeper and richer when they create something. So working with them is perfectly all right. In fact, some of my best experiences with students are when I was like, kind of at the fringe of my knowledge here, let's learn this together. They love that and really take off with it, and they have a lot more buy-in.
Avery already spoke about this quite a bit, and we're just a little bit behind on time. So student ownership, general term there is you get students involved. Some of the stuff I'll show you, remember that some of what we're showing up here, you should have your students just develop it. You should be the person developing, even if it's lesson content. They're the people that develop it, and they structure a lot of lessons, and even get them involved in the assessments. What's supposed to be assessed here, and how should we assess this? Developing assessments. I mentioned earlier we were talking STEM with an industry tie, but we obviously always have to be focused on standards. So we're doing a couple of things here. We've got a project-based learning environment in the STEM environment, tied to industry, and we're focused on standards. So we're asked to do a lot as teachers. But as we go through this, we'll talk about standards and how to connect those and get some ideas from you also. The sheets you have, the worksheets you have. So on the right-hand side of that worksheet, the project, yeah, that one with the boxes to fill out. This is our process flow for creating a lesson. So we start with the industry problem. We start with the industry problem. We look at the problem, we move on to the assessments and then standards. Because we're assessing the industry problem, but we know we've got to tie to these standards also. So this is our flow because we have a different audience than you. We're supposed to be focused on industry and provide that for teachers. You all probably start right here. What standards do I have to cover? So you're going to have to work from that way back, because once you get your standards selected, understanding by design, right? Start with the end in mind. So you've got your standards selected that you want to cover or have to cover. Then you're going to figure out how to assess those standards, and then at that point, you may want to figure out what the industry problem is. Now, for you all, there's kind of a problem in this loop right here, because now you know how you want to assess that standard. You've got to somehow fit a project into that assessment. What kind of project can you do that'll fit in that assessment? That's what we'll talk about today, is some project ideas, and hope we can walk away with some ideas on how to do that. And always, are the standards covered enough? Are the assessments covered enough standards? If you're going to do projects, some of the projects we'll talk about are an hour long, some of them are several weeks long. If it's several weeks long, we know you all have to cover a lot of standards in that period. So that's when we go through kind of a validation loop. Are enough standards covered to make this project valuable to the teachers?
Which is a huge benefit because we're all being asked to do more with less. So if you can cover 20 standards in a day and a half instead of maybe the 8 or 9 that you would have otherwise done, that can be a real benefit to you if you're getting lots of material in there.
We laid out the sheets today, so you can just pencil in on the side. As we go through and you get ideas, you can start putting those ideas in there and build a lesson.
So Rick, like, what part of the job, if I say I wanna, incorporate some biology with a biomedical engineering, I can come to you or can ISD to help me make those contacts to the industry?
Yes, and I'm going to show you another method to do it that is not quite a magic bullet, but it's pretty close to making or enabling you to find that information yourself. But we'll talk about that in a bit. But we are available to answer that exact question. Like I mentioned earlier, I work a lot in industry. He's worked a lot in industry. We've got a lot of contacts, so we definitely can provide that. It'll be a volume question, right? I mean, a lot of people call us, we're not going to have time to respond. So
Another piece of this is as we go through these next couple of lessons, we've kind of talked about the STEM argument piece. Now you're going to start seeing some examples of Rick and I's work making some of these lessons. As we go through these first couple, see if you can get used to this process, find the industry problem, any assessments that were standards, etc. Okay? Try and fill out at least one of these sheets on one of the lessons as we present it. So some of what we do, like I just said, we develop and assist in creating lessons K through 12. K through 12, we're teaching engineering at the kindergarten level. It's doable, okay? And it's actually kind of a lot of fun when you're doing that. We focus on the engineering and the technology. We don't just mean an iPad or a computer. We mean this stuff, that stuff, that stuff. What is actually being used out there so the students have that application. This one's you, right?
Yep. So now we're going to start talking about some lesson examples and how we build these lessons. We've been kind of talking about STEM thinking, how we put all this together. These are actual lessons, and we're going to go into what the lessons are, how we structure them, and then we're going to go into the actual technology used in the lessons. Right now, we're just talking about the lessons. This is a company here in town, GWI Engineering. They do robotic welding arms. So when you've got a part coming down the factory line, I've got a bunch of robotic welding arms come in. And what's important to know about this video is, let me run the video. It doesn't have any audio, so I can talk through it. So this is a welding cell. You've got the parts welded here. You've got several robots working all at the same time. And if you can imagine, when they weld these parts together, what they're talking about right now, where do we have to weld this? Where is the strength at? Where do I need to put a spot weld or weld something together? They're also going through the fixtures that actually hold these pieces down while they're welding them. They design the machines, so how are they going to design this machine? And remember, they'll design one machine like this, and their customer may have hundreds of different type of parts that come through this machine. So they're designing one welding machine, and there's got to be a controller. You see the controller in the background here. That controller holds the program for that specific part, for that specific machine. And that's what a lot of engineering in that environment is what have I got to weld, what does the part look like, what kind of machine do I got to build to do it, and how do I make that machine do what I want it to do. We're going to talk about coding today, and we'll talk about this type of coding. We're using PLCs, programmable logic controllers. So a little different than I think a lot of people are used to with programs and applications. When I do talk,
Hand out this one, right?
sure, but we're not going to use it yet. But go ahead and pass it out.
Okay.
I'll talk about coding. This is a lesson that is software coding, but it's just using a piece of paper. It's called the Hanoi Towers. It's been around forever, and it's just a way to learn programming. And I'm actually going to go into Edify. I wanted to show you Edify at this point. So we're going to go through we're going to talk about Edify and how to create a lesson here later. But you can follow along if you want to log back into Edify. What I'm going to do up at the top, I want to go to Manage Lessons. Right now we're on Resources. We'll talk about what a resource and lesson is, but I'm going to pick that Manage drop-down and pick Lessons. And I'm going to search for STEM KISD. We're using that for all the lessons we've developed. And the one I'm going to pick is this recursive logic down here. It's the recursive logic lesson. Okay. I thought it was going to give you grief.
Good working for everybody?
Sample course, right?
So just to go over the Edify structure, when you log into a lesson, the teacher's introduction to the students, a lesson summary, but the body of the lesson is down here. And actually that video I just showed you, that is the start of this lesson. So we've got a primary resource on every lesson in Edify. The lesson starts with a primary resource, and that can be an anticipatory type of video. It does have to be a video or an image. So every lesson in Edify has that primary source. And then down below that are the additional resources. These are the support materials to actually do the lesson. So the lessons we're developing will have things like the student worksheets, which is what Avery just handed out. Student worksheet, the lesson guide for the teacher is in here. And this is what we'll have you work on later on today. And also some additional videos. And actually, as I do that, I realize I'm playing that. We're going to do this later, so. But just wanted to give you an overview of what Edify looked like, where it's at, what these parts are.
So, long story short, there's a primary resource, other resources including a lesson plan and maybe a student handout, and then there's an assessment at the bottom, overall structure.
So we'll go through that when we actually talk about coding. And it's a game. If you want to cheat before we do that later in the morning or afternoon, you can look at it.
Oh, they don't want to cheat.
But I will point out, I've got standards here. Y'all mentioned the next generation science standards. One of them is determine an explicit expression, a recursive process, or a step for calculating from a content. So some of these things we haven't had to do before, right? Recursive process, what the heck does that mean? We do it a lot in coding, so we'll do that later this morning. So the lessons we've got up there, all the lessons we're creating do contain these things: industry problem, connection to a local company, an introduction video, a teacher guide, student guide, a pre- and post-assessment, lesson resources and additional resources. That pre- and post-assessment, the way Edify is set up, when I create a lesson, I've got standards attached to that lesson. If the student does not pass the assessment, Edify goes out and finds other lessons that have the same standard attached to them and gives the student back a remediation list. These are other lessons that cover that standard. The student then has the option of going to those other lessons, doing those lessons, and coming back and trying to pass the assessment for this lesson.
Automatic. You do nothing.
So it does have a remediation built into Edify. That's all tied on to standards, which makes it important when you're developing a lesson that you've got a standard in that lesson that you're tied to, so that student can then get some remediation. Of course, there's always a student teacher guiding the student through that, but this keeps the student moving, right? They're not waiting for a teacher to come work on remediation.
So this is an example. We're going to get more into this lesson later as an example in the day, but logistics engineering. Target audience for this is a sample video lesson launch, but the target here is lower L, okay? And like Rick said, some of this stuff, you got to have software, computer. This is an example of one, and there is software for this as well, but this is an example of one where you don't have to have that. All I've got is a dry erase board and some sheets of paper. So we got 1, 2, 3, 4, 5 packages onto his truck, right? Well, what if we had smaller packages on the truck? Could we fit 5? Or do you think we could maybe fit some more? What do you guys think? Let's try it. I've got some smaller pieces of paper here. They'll be like our small packages. So there's one of those. And hey, look. This is the space where I had just one package before. Now I've got 2. So you could talk about, you could go 20 different directions with that. You could talk about how much it costs and money. You could talk about fully utilizing the truck. You could talk about what percentage it is full. You could talk about fractions. Okay, there's 2 of those where there used to be 1. So just a really quick example.
So industry connections, what we're doing right now is we're going out and interviewing engineers out in industry. This is Brian Rodney from AECom. And what we're asking the engineers to do is to state an engineering problem. And it might not be a problem to them, but it's a type of process they use. So we sit down with them, we have them state a problem. I'll let you hear him over this example here.
As garbage trucks come into the facility, they have a tendency to leak. You've probably seen leaky trucks before. The problem is compounded whenever it rains, because when they come in and they go in and they dump their load onto the tipping floor, and it's covered, there's no rain being exposed to that. However, because everything is wet, they trap water in, they dump the waste out, and there's a lot of liquids that come out on there, and then those liquids can get tracked out back outside, and when that happens, when it rains, that runoff gets into their drain system here, and that drain system goes out to an outfall underneath Market Avenue directly to the Grand River. So those pollutants that are coming out of those garbage trucks have been getting into the Grand River, and therein lies the problem.
Therein lies the problem. And notice the documentation. Whenever you've got an engineering project, you've got a lot of documentation, the drawings themselves, satellite images, and then all the reports of this. So in this particular problem, Covanta, the waste-to-energy plant, they bring a bunch of waste in, they burn it to make energy. They had high metals, and high metals were out in the Grand River, actually. They couldn't figure out where they were coming from because they weren't coming out of the plant. Turned out the garbage trucks leaked at the parking lot when it rained. All that stuff went out in the Grand River. And that's what they're trying to remediate. We walk the students through this lesson. And the way we start this, so I've got one in this,
Real quick, the biology teachers out there, total aquatic load, things like that, it's not just, there's 15 different things all happening there. So try and think in those terms.
in these next several slides, I'm taking that one industry problem, and for an elementary audience, we're just looking at that parking lot, we're looking at shapes and areas. So the start of this engineering problem for all the grades was, what is my working area, how big is it, what area am I actually trying to remediate or work with? So that's the upper elementary. We start talking middle school, well now I can do things like have some odd shapes in here. We've got to estimate a little bit, we can have arcs, circles, and they've got to figure out the area of that. But we don't have to stop there. This is just, just a real simple example of how I'm starting with now. But again, same problem, I'm stepping up the complexity of the solving the problem. When we get to a high school audience, now we're actually using real engineering drawings. We can talk about volume, flow rates, actual chemistry to get those heavy metals out of there. Or if we're going to develop a sediment pond on the side of this, that's the high school level. So the idea there is one problem, we keep scaling up the different grade levels.
Yeah, can I just add one piece? That since Avery talked about thinking outside the box, if you are the high school level and a science teacher or a math teacher of teaming up with someone in your building, you don't have to have the same students. You can be talking about the same topic, and the students that do have the same teachers can make those connections. But it's just for a small unit, just to bring some meaning to each of the courses and that relationship between the two courses.
And we're seeing a lot of that right now. Teaching different subjects.